Alright, so this is the video for 8-1A, so we are going to start Chapter 8, and Chapter 8 is talking about similarity, and we have talked about similarity when we talked about transformations. Remember, similar figures mean they're the same shape but different size, so like when we dilated a figure, it got bigger or smaller but it didn't change. Those are similar figures, so this whole chapter is designated to that. Hopefully you did the worksheet where we remembered how to solve for a ratio here. So if you didn't, okay, remember we just cross multiply. I think some middle school teachers talk about like the butterfly method or something. So what we do is we cross multiply. So it's 3 times 4 is going to equal x times 8 or 8x. Okay, well 3 times 4 is 12. Divided by 8 on both sides, you get 12 over 8 is equal to x, which is, what, 3/2? Okay, or 1.5 if you like fractions. Okay, so go ahead, take a minute, pause this and do B on your own. Alright, so hopefully you went ahead and worked it out and you get 38.5. Okay, we're going to do lots and lots and lots of setting up and solving for ratios in this section. All right, similarity statements. And see here it says again, recall from chapter 4, that was our translations chapter, or transformation, sorry, that geometric figures are similar if and only if there is a similarity transformation that maps one figure onto the other, okay? And that will, because it changes sides, that will include a dilation. Okay, now that doesn't only include dilations, it could include a dilation in a translation or a dilation in a reflection or whatever, but there is a dilation because it gets bigger or smaller. Okay, and how much bigger or smaller it gets is known as the scale factor, and we'll get to all this here in a minute. But remember, the scale factor is how much bigger or smaller it gets, and we label that scale factor as the lower letter K. So that's what this K means right here. Okay, so essentially we multiply all these sides by the same number to get this bigger shape. So you can write triangle ABC is similar to triangle DEF as triangle ABC is similar to triangle DEF. And remember, this is the symbol for similar. So if we go down here, it says a similarity transformation preserves angle measures. Okay, what that means is the angle measures stay the same. Okay, the angle measures don't change. So even when it gets bigger and smaller, the side links change, the angle measures stay the same. So that means that corresponding angles are congruent. Okay, so corresponding angles, remember, are in the same position. So that means that angle A is congruent to angle D. Okay, that means that angle B and angle E, which are both in the middle, are congruent to each other. Angle B and angle E, which then means that angle C and angle F are also congruent. This is an E. A similarity transformation also enlarges or reduces sides by a scale factor. This is what we talked about briefly. And once again, for reasons that I'm not sure of, I probably should look it up, we designate scale factor with a lower letter K. So corresponding side links are proportional. Which means that if we have the scale factor, okay, it's going to be DE, which is the first two, over that corresponding side is AB. EF, which is the last two, over BC. Or FD, which is the last and first, to CA, which is the last and first. Okay, this here, we call this the statement of proportionality. All right, so let's look at some examples. Okay, let's look at example 1a. It says in the diagram, RST is similar to triangle XYZ. So these two are similar. Okay, find the scale factor from, this is key, from RSC to XYZ. So that means we start with triangle RST, we end with angle or triangle XYZ. Okay, now remember what we start with is the pre-image, and what we end with is the image. Okay, and we learned back in chapter 4 that we can find the scale factor is always a length of the image over that corresponding pre-image. Okay, so here all we need to do is find corresponding lengths. So RS is right here. Okay, and that corresponds with the first two over here, XY, which is right here. Okay, so the length of the pre-image is 20, the corresponding length of the image is 12. So we can find the scale factor as image over pre-image. Okay, well the image is right here, it's 12, over the pre-image, which is 20, and yes, we do want to reduce that. So what is that? 3/5, okay, or 0.6. Now remember, if the scale factor, if this is bigger than 1, it's getting bigger. If it's smaller than 1, it's getting smaller. Okay, list all pairs of corresponding angles. Okay, so I like to do this straight from the similarity statement. Okay, so just pay attention to the order. R and X are the first two letters, so that means that angle R is congruent to angle X. S and Y are the second position, so angle S is congruent to angle Y. And then the third position is T and Z, so that means that angle T is congruent to angle Z. Okay, so once again, corresponding angles don't change. Write the ratios of corresponding in a statement of proportionality. Okay, so this is what we just did. So K, which we found out was 3/5. Okay, and that's the image over the pre-image, so that's XY over RS. Okay, and that's going to be the same as YZ over, for last two here's ST. And then don't forget the first and last, so like XZ over RT. That is a statement of proportionality. That just means that we can try any of these proportions and it'll come out to 3/5. Okay, go ahead and pause this video and I want you to do example 1B on your own. Alright, so this is what you should have gotten now. You should have noticed that we're going from ABC to JKL, so we're getting bigger, so our scale factor should be greater than 1. Okay, so if you take any of these three, I just took the ones on the left. If you took the ones on the bottom, you'd get the same thing when you reduced, but our scale factor is 4/3. Okay, I looked at the orders of the similarity statements to find corresponding congruent angles, and then here is our statement of proportionality. Okay, now we can use this information to find lengths of missing sides. Okay, so corresponding lengths in similar triangles. Okay, if two polygons are similar, then the ratio of any two side lengths in the polygon is equal to the scale factor of the similar polygons. Okay, so we're really going to use this and then set up a ratio and solve to find missing side lengths. Okay, that's what we're going to be doing a lot in this chapter. So it tells us in the diagram, triangle DEF is similar to triangle MNP. Find the value of X. Okay, well X is right here. Okay, and X represents EF. And so I know that corresponding side to EF is NP because of the relative positions. Okay, so I'm going to set this up as X is to 30 as, now I just need any two other corresponding sides, so I don't know, let's just do the first two letters, which is DE, and this is DE, and the first two letters here, which is MN, so that's right there. Okay, now if I put X on top here, I have to put from the same triangle on top, so it'd be 15 over 18. Okay, then I can cross multiply. So we have 18x equals 15 times 30. Okay, and 15 times 30 is 450. And then if I divide both sides by 18, I get x is 25. Okay, so the length of this side here is 25. Okay, I want you to go ahead and do the same thing on B. Okay, find the value of x by setting up a proportion. Now, I do want to say there are multiple ways you can set up correct proportions. That's okay. So I'm going to go over it once you've done it. But if I have it different than you, we got the same answer, you're perfectly fine. All right, so hopefully you paused this and did this on your own. And when you did, you got that x is equal to 18. All right, let's do a couple more examples and then we'll stop for the day. Okay, so these aren't just side lengths, these are parts of triangles as well that you have the same proportion. So notice it says in the diagram, this triangle here is similar to this triangle here. Okay, we want to find the length of the altitude PS, so this is what we're looking at. Okay, well notice we have the altitude of this triangle on the right, which is 20, and these are going to be corresponding parts, so these are going to be the same as like corresponding side lengths. Okay, now we want to find parts of other triangles that correspond. Okay, and I'm just going to use the 6 and the 8 because why not? Okay, you could use 6 and 6 is 12, 8 and 8 is 16. You could use the whole side. You'd get the same answer. That'd be okay too. Okay, so now I can set up a proportion. So x is to 20 as 6 is to 8. Okay, remember the 6 goes on top because the x goes on top, and these two are of the same triangle. Okay, if I would have put the x on bottom, that would have been okay. Like if I would have written it as 20 over x is equal to, this would be okay, but I would have to match it. 20 is on the right, so then 8 would have to go up here. Either one of these, you'll get the same answer, okay? It doesn't matter. I'm going to X that out to not confuse you, hopefully. All right, so when I solve, we have 8x equals 6 times 20. So 8x is equal to 120, which is 15. 8x is 15. Okay, I want you to go ahead and pause this and do B on your own. All right, so when you set up a proportion and solved it, you should have got the median here is 27.